Hey guys, Assalamualaikum and welcome to Engineering Dynamics with the topic Projectile Motions. I want you to focus about 10 minutes in my lesson in my video, because at the end of the lessons there will be instructions for your assignment that will be a bit challenging, but for engineers, the more challenging the problem, the more interesting the job. Believe me. Okay, at the end of this lesson, I'm expecting, that's such a big fish. I'm expecting you to be able to design the right trajectory path with related to engineering applications. Of course, this will involve a bit of mathematical modeling and also numerical analysis, but it will be interesting. Are you ready, guys? Can't wait to see your excellent videos output. Can you see Dory? Where's Dory? Ah, that's Dory. Hi, Dory. Bye-bye. We can divide the type of projectile motions into two. The first one is without the shooting angle, and the second one is with the shooting angle. Consider a ball at point A at a certain height h. A boy kicked the ball with initial velocity Vx, and the ball will then take a parabolic path to point B. The question is, what is this distance r? Note that the horizontal velocity Vx is still constant along the path, and thus r is simply Vx multiplied by the times from A to B. So the next question is, what is TAB? Okay, to show you the derivations of the equations, let me scribble here in this Sketches School app. The ball has initial velocity Vx in horizontal directions, and the ball will have this parabolic path along the way before it touches the ground. So let me draw the ball here. So why does the ball have this kind of path? Yes, correct. This is because the gravity that pulls down the ball. So you can imagine if we don't have gravity, the ball will go straight without ever touching the ground. Now, if A is the initial positions of the ball and B is its final positions, and we want to know the distance r, it is where the ball landed relative to the wall. So this one can be easily calculated by multiplying the initial velocity Vx with the time required for the ball to move from A to B. In this case, we know the initial height of the ball, so we can use the dynamics equations where the final y positions equals to the initial y positions plus velocity at y directions multiplied by time plus a half accelerations multiplied by time square. Okay, so if we set point A as the initial y, where let's say ya equals to 0, and we can set our own agreement that everything below A is negative, so yb equals to minus h. And thus the final positions of the ball is minus h, and then the initial positions is 0. And again, this is the most important concepts, that along the way, the ball has only the vector velocity in x directions and not in y directions, and therefore Vy equals to 0. The acceleration here is the gravity that pulls the balls towards B, and therefore it has minus sign. And from here, we can have t, which is the time required from A to B. Let me change the color first. So TAB equals to the square root of 2h over g. And This is the most interesting part. You notice that this is the time required for a free fall body. You've got this concept already in your high school, I believe, which means the time required for the ball to fall from point A to, let's say, point C. This implies that TAC equals to TAB. If you think again, that this really makes sense since the path AC is shorter than path AB, but the ball falls without initial velocity to AC, and the ball travels with constant velocity along AB. So they will arrive at the same time. This was a simple experiment we conduct inside our faculty building. One of my students released the ball, and at the same time the other one threw the ball horizontally. So we can see that we prove the time arrival of the two balls is the same. Let's see this again. All the process of recording was using my iPad's camera, using the slow-mo functions. Really cool, isn't it? And therefore R depends on initial velocity Vx and also the height of the ball. Now your assignment is to explain in details about projectile motions with angle. I'll give you some clues. For projectile motion with angle, we now have both horizontal vector Vx and vertical vector Vy. When the ball reaches the maximum height, the vertical Vy becomes 0. This makes sense because the ball cannot go up anymore, so it doesn't have vertical component, and we live only with the horizontal vector at that position. The ball then goes down, and you should note that the vector Vx is still the same, and the vector Vy now going towards the same as gravity, so we'll have negative signs until the ball reaches the ground at point B. So the question is still the same: what is the distance r? As the horizontal vector Vx is constant along the path, the distance r is still calculated by Vx times TAB. Same as the previous case, if we know Vx, then we need to know the time from A to B. Alright, so this is your assignment, which consists of 4 parts: introductions, theory, numerical analysis, and documentations. For introductions, you have to create a short movie using Clip app. It should highlight what is the projectile motions, what is the applications of projectile motions in engineering, and the video should be less than 2 minutes. So your challenge is to create a short movie but informative. For the theory, you have to also create a movie. So your movie must briefly explain the derivations of the equations. You have to give one example of calculations, and it cannot be more than 5 minutes. For this task, you have to use Keynote, Sketcher School apps, and also iMovie. In Keynote, instead of using it only as a slide for text and image, you can also perform animations to suit your story. So let's insert a shape of object, for example, a helicopter. And we want to animate something from the helicopter, so we can insert a line. So animate, let's change the size. Okay, choose line draw, and then play. Okay, so we can copy the same line, put it together, and then modify the path. So change the size and the color. If you play the animation, and the second line. Okay, so this is what we have. Now, in Keynote now you can insert equations. So equation is based on latex code. So insert, you can enlarge the equations and then drag and put it in the positions. You can also draw on the keynote now. So let's draw an angle for the second line. Great. You can now insert your voice to explain your slide. So tap plus, record audio, and if you're ready, you can tap record. This is the path without shooting angle. Tap insert, and if we play that again, this is the path without shooting angle. Let's record one more voice. This is the path with shooting angle. Insert. Let's put the icon first at the right positions. So if you want to animate, press animate. And we want to animate the drawing, so press line draw. Put the drawing just before the line. So everything in order now. So the drawing should come after previous build. If you play the animations, this is the path without shooting angle. And it should come out the second line now. This is the path with shooting angle. If the animation is done, then we can export the animations into video. So choose movie and choose the vertical resolutions. 720p is already okay. So it's creating movie. And choose how to send and save video. So the video will be saved in your photos. That's it. Another good apps you can use to present your idea is Sketches School app, which offers some more flexibility in terms of sketchnoting presentations. You can use the record screen on your iPad and start scribbling on the screen. Very straightforward. You can assemble all your videos in iMovie, a very handy app to create movie in iPad. So choose one movie, tap create movie, and then there we go. If you play the movie, this is the path without shooting angle. If you want to add another movie, just tap video in the media, and then choose one movie, tap the plus button. You can easily remove the portion of the video by dragging the video. And you can also record your voice in the iMovie. This is the Sketches School app. Okay, so let's play that again. This is the Sketches School app. Tap done button if you're done, and then save your video. Choose HD for example, and your video will be exported into your photos library. For the numerical analysis part, you have to plot the trajectory path of the projectile motions, and you have to create the effect of initial velocity and the angle on the trajectory. For this task, you have to use the Numbers app. Let's plot the XY Cartesian coordinate, and let's say this is the trajectory path. So what we have in x-axis is the equations where x equals to vx multiplied by time, and in y-axis we have y0 plus vyt plus half acceleration times square. X and y are basically as a functions of time. So for every value of x at certain time, we also have a value of y. So this is x at t1, x at t2, and so on. And similarly, this is y at t1, at t2, and so on. So we can then connect all the dots to form the trajectory path based on the equations. In Numbers app, what you have to do then is to create a series of time values, and from there you can also create the x value using the formula. If you look at here, x is multiplications of a value in A2, which is the velocity to whatever the value of time in B2. And also the same thing for y. Then we can plot x and y by selecting the scattering chart. And we can produce the pattern of the trajectory. From this graph, we can also see how the path is changed if we change the initial velocity Vx. We change it to a smaller value. You can see that the path becomes shorter. Let's change it to a larger value. It's become longer. Really cool, isn't it? Don't forget that your numbers will be much more interesting if you can creatively put relevant drawings. Remember that engineers must also have the sense of art. How about that, huh? Okay, your task is to produce the similar graph in numbers for the case of projectile motions with shooting angle. It will be interesting to see how the path is changing with the change of velocity and also the angle. Your model must be able to show that if you input theta equals to 0, the graph will return to the one without shooting angle. For the documentations, you have to put all your created content in pages. So this includes the clips, the iMovie, and also the graph from the numbers. The maximum pages is 6, and submit to me the pages file and also the number file. Open Pages app, create document, and choose the book template. Let's choose this one. Just tap on the text and change the title to Projectile Motion. And also change the author with your name. Now I want to change this image into a relevant image for this topic. So let's bring Safari into split screen so we can see both apps side by side. In pixabay.com there are tons of free images. And let's say I choose the one that I want. Just tap and hold and drag the image until you can see the plus sign and release. Super easy. Let's go to the next page. So we can change this one into, let's say, introduction. Because I want to insert the video, so I delete the image and also I delete the text. Now let's change this one as well, about projectile motions. And we delete the text at the moment. Okay, just tap plus and insert the video. Very straightforward. Okay, so do this also for your main video about the theory. Insert your graph from numbers, create relevant sections, add relevant text, etc. and submit this book to me.